Um, right, I'm making a short video. I'm going to try and keep this as short as possible, really, because I don't want to be spending all night uploading. Right, this circuit I'm building is, it's upside down right now, using an op amp. Could go up to 15 megahertz, and I've got a dual rate supply set up there, which is driving a hex inverter. Now, the key to getting this circuit is to drive a trigger circuit in this oscilloscope, but I'm going to be driving it through the external trigger socket, but not at the moment, because I'm currently setting up the waveforms. The idea is that the output should always be clean and stable for the trigger circuit only, right? Well, the input waveform can change dramatically. Now, if I switch, I'm not going to twiddle about with knobs and frequencies, but I am going to switch from high frequency ranges to medium and low. So what happens, the input waveform is the triangular looking thing. The output waveform is the squarer looking waveform. Right, so when I switch to a lower frequency, notice that these lines here haven't changed very much, whereas the other ones have changed dramatically. Now I'm going to switch to another lower frequency. Now you'll still see that these lines have hardly moved, but I'll have to change the time scale to actually get to see these waveforms. Actually, that's a bit too small. I haven't got a trigger lock, and I don't want to mess with the trigger lock right now. Now, this is a problem with scope, trigger locks. Let's go to a low frequency. Now, you'll see that the... now, let's try and get a trigger lock on here. Now, let's change to a square waveform on my signal generator on here. Now, for some reason at the moment it's not changing on the input either. Well, on a triangle now. Sorry, sine. Now it's on a square. Now it's on sine. Now it's on triangle, but the input isn't changing either. So there must be some kind of back feedback or something going on there. But anyway, let's go back up in frequency. Now, when I get up to the maximum frequency, we do see a little bit of attenuation going on with the amplitude, which is due to the frequency response of the chip. So the object I'm trying to achieve is, I've lost my lock now. The object is to try to get the output waveform to always remain constant in amplitude and squareness. So I'm still working on it. It's not perfected yet. But when I change the sine, now look what happens. The output is changed slightly, which is a problem. It's actually more bottom-ended than top-ended. Right, the input is still looking the same. It's just lower amplitude. So the input amplitude can change quite dramatically, and the output amplitude won't change much at all. Now the input amplitude is even higher, but the output amplitude is about the same. Right? This is the objective, is to produce a stable signal for the trigger. Right? So by just changing, this is just by changing from square square to sine to triangle. Right? This is all I'm doing right now. That's square, sine, triangle. The amplitude of the second output waveform isn't changing the amplitude very much at all, and that's good. But I still need to get it squared up, and I've got decoupling capacitors, try to filter capacitors and all sorts of stuff. Anyway, I'm just showing you where we are at the moment. Still more to do, but now let me just attenuate the frequency a little bit. This is frequency adjust. Now we see I'll lose the lock on the scope. I'm going up in frequency, down. I'm actually going up in frequency, right? That's maximum frequency on the audio side of it. We lost a bit of the input, but the output isn't changing much. Let's see again. See, the input's changing quite a lot, but the output is constant. As I shift the frequency, obviously we're losing trigger locks there, but you see the output is these lines here. Right, and I'm changing the frequency and the output is pretty constant. That's the whole point. Okay, thanks for watching. Which button is it?